Our dimensional complexity of our data really is growing. The scientific progress that's happening around it means it's not going to be good enough to just do a quick linear regression and expect to get something back out of your data in sort of where we live most of the time these days. Higher data volumes are becoming more standard. This is much more off of your instrument, and it's getting harder to wrangle it all manually. So, as a human, you're only going to be able to work in two or maybe three dimensions. When your data has 17 dimensions, which frankly is small, you're going to need some better tooling. That's where we're going. Next slide. Adam, why don't you start us out with a little bit of a description of what we're looking at and where we're going today, some of the tooling we're going to start to look at.
Sure. Well, just real quick, James, you mentioned some things like, having labeled data or structured data or where is our data, and I think it's important to emphasize that point that a lot of the companies that we talk to, a lot of the projects that we're looking at helping out with, oftentimes there's everybody's thinking about, okay, well, like what machine learning, algorithms, what do we apply to this to sort of get the answers? But, oftentimes what we find is, you really have to start taking some steps backwards to really think about what's feeding into that, right? What questions you're asking, things like that. And so, to sort of couch this conversation, I think everyone here, you'll find that we're going to spend a lot of time talking about that data side of things, getting prepared, getting the process moving and what it means to really put one of these solutions in place. And so, we're gonna stay pretty high level. Some of the things we're talking about here, we've talked about a little bit before in more depth, and I think we'll do some breakouts. But we really, again, really wanting to focus on that, getting started, asking the questions about what you're doing and how how do you get started, and our example for that will be sort of this idea of doing some image classification, categorizing images, and taking a data set that might start out as very disorganized, lead you maybe sometimes feeling like you've got more questions than answers, more process to dig through to get rolling. And how do you get started? So we'll take a look at this concept of saying, look, we have these particle image samples, and they're going to show up in these images, and we've got some examples here, and they're different sizes, and they're kind of blurry and fuzzy. And how do we make sense of data like this? And if we wanted to just simply say, hey, we want to categorize these into simple shapes, how would we start and go through that? What's that process that we look through, or that we go through? To get us there to an answer where we could, reliably apply an approach to have a computer look at those images and say, that's a spiral, that's a rod.
And to be clear,
Um,
this is real data that we're looking at. If it's not exactly your real data, there should be some familiar bits.
mhm. Yeah. Yeah, it should be. And we hope that as you're thinking through this, you can kind of see some of envision the problems that you have, the questions you'd like to answer, and how do these approaches apply. So we'll talk about some tooling, some ways to get going, what it means to even have labeled data, and some of the process of putting those things together. And I think in our next slide, Austin, if you want to move ahead. We'll talk about what we hope to accomplish today is really walking through that process of sort of formulating that plan. So what questions are you trying to answer? Because depending on what it is you're searching for, there are different approaches that you can take, different machine learning algorithms, different needs for data. And there are a lot of considerations again upfront. Any good experiment, any good project benefits from upfront planning and understanding of the criteria that you're trying to measure. We'll talk about that data preparation process, some tools, how those tools infrastructure can help get things prepared. We'll talk a little bit about the algorithms and selecting and why you would choose certain techniques versus others. And I think one of the most important points that we are always sort of beating the drum about, James, is the iterative model that all of these projects take.
Let's jump ahead and start to look at the data, but I do want to follow up Adam's iterative comment there. Um, the One of the important points here is that this is a kind of experimentation. It's dry lab work, but it is a kind of lab work. You are exploring what the data is going to give you back, and you should not expect to get the answer right the first time. Instead, let's plan that we are going to iterate. So that's part of your plan, right? So we're going to start today. We're going to look at some of those images that Adam mentioned, and we're going to ask some broad questions. We're going to categorize them, maybe based on shape. That's our starting point for this. We don't expect it to be perfect out of the gate. We're going to iterate. We're going to do that today. Jump ahead one more. So
Oh, go ahead, James.
no, this is the kinds of images that we're going to be looking at, and we've pre-categorized them maybe a little so that we have something to demonstrate what we're talking about here. We've picked three shapes. We've got some circles, we've got some rods that are a little more linear, and we've got some spirals that don't classify neatly into one of those first two categories. And you're going to have to squint because we are looking at some microscopic data here, but you should start to see the trends that we're talking about. And that's usually a good starting place, is that first intuition. I can kind of squint at that and see some trend there. How do we capture that? How do we capture that intuition?
So you want me to take this one, James, a little bit,
Sure, go for
start
it.
diving in. So, I think again, one of the things that we want to emphasize, and one of the things that we find a lot is in embarking on these projects, people are often asking the question of, okay, well, like, what do I need to get ready here? Like, what do I need for data? And it may not exist in your organization, or it may be all over the place. That you may have information that's, on an instrument, on a computer over in one side of the lab, and others that might be in notebooks. You might have gaps in, the data that you want to capture. If you don't have the right data, then it doesn't matter what, the AI machine learning algorithms you apply to it. Um, you know, uh, it won't be feasible. And so you really need to start when you're looking at this is sort of like, what are you starting with, and is it going to be sufficient for your needs? And oftentimes, is there infrastructure in place to make that available, or to collect that? James, a lot of the projects we work on start with, putting in some sort of automated pipelines for, manipulating, transferring, or transforming data in ways that make it accessible to downstream experimentation. That's concept that should be familiar to anyone in the lab space.
It is, and it's one of the most frequently missed pieces when you are a laboratory organization. You've invested significantly in your physical flow through the laboratory, your storage of samples, how things will be analyzed, how to move efficiently through that space. If you've not done the same in your dry lab processes, you are going to struggle a little bit. That's one of the things where we frequently find we need to come in and provide a little bit of support, is to get things set up to do that. But we need the subject matter expertise. that we cannot bring the expert that to the data that your organization has. You know it better than we do. So we're really, really looking for that intuition that I was mentioning before. Somebody in your organization needs to already have a starting point for an idea. What should I be able to get back out of this data? What should I be able to find in this data set? And the intuition of the person who's closest to it is often our most best starting point for how we're going to do that. Um, to get off the ground, though, that's sort of the investment question down here at the bottom. It's going to take time to set this up, and it's uncertain what you're going to get back on it. So the goal is to find some early success, some minimum viable data set that's going to prove out the concept and start to show that there is value in the data, and maybe we just need to refine the approach a little bit. So let's go ahead and jump forward one more.
Well, before we do, James,
Oh,
let's
yeah,
talk
no,
about that context here.
go
So,
go back one, Austin.
we
Yeah.
brought up the idea here of, how okay, like we've got these microscopy images, like why would we want to to be categorizing these, right? Well, like
Yes.
what's the investment? And this is actually yeah, as James said, real data that we pulled in in sort of image classification applications such as this, you may be looking for things like anomalies in the data. You may be looking for trends in this particle analysis case. Perhaps you're analyzing, the expected images that you're going to be seeing for deviations. So that could be from a calibration standpoint on instruments to actually running experiments to see how environmental or other factors are affecting sort of the outputs. Whatever the case may be, coming through and looking through these images by hand as an individual is fraught with issues, right? Obviously, there's a lot there, right? It could take, a lot of time to go through and classify those. And I would say that because we have done this as individuals, that's also a process that is prone to error when done by
And
humans.
to be clear, it's exactly where we're going to start today. We're going to try and hand label some images.
Yeah. And so, in embarking on something like that, you've got to say, well, faced with all of these, all of these processes, all these roadblocks to getting started, like why? Why would we even go about doing this? Um, and for and that helps sort of, is at an organizational standpoint. Value, the investment in embarking on one of these projects to understand, okay, can this work? How well does it work? And iteratively improve it to a point where the value that you're seeing from the application is much more than the investment that you put into developing the process. We talked a lot about labeled data here. Perhaps it would be a good idea to also make sure that people understood what we're talking about there, which is, the idea that yeah, as we're going into the process of classifying these images, we also have to have labels associated with each individual image to, feed to the algorithms, if we're doing something like supervised learning where we're saying, look, you have these are all of your rods and these are all of your spirals, and you're feeding those to the algorithm so that it can understand from images that are known how it might extrapolate to images that are unknown. Um, so with that in mind, we want to talk a little bit about sort of like that first structure and the idea of, or this first step, which is, like how do you begin taking the data that you have and getting it into a form that can be fed into models? And this might be, a necessity to take, disparate data and combine it together into to spreadsheets. In the case of, something like images here, you might have a large TIFF like you see here with, reams of images that are neither consistently sized or, have consistent aspect ratios. And for something like computer vision, those need to be normalized somehow, and in some cases augmented in particular ways before you can even feed those into the algorithms. And so, whether or not you're talking about image manipulation or normalizing data, the long process of sort of getting it into a format that is usable needs to be one of the first parts of the process of developing out a machine learning algorithm.
Go ahead and go to the next slide here. So, how are we going to go about doing this labeling? And for the moment, we're going to demonstrate a tool that we use to actually do some of this manually. This is Label Studio. It is an open source tool. Adam and I independently stood up copies of it, grabbed the data set that we were just showing you, and started going through image by image. And you can see we set up just some different categories of things down at the bottom. Notice when we originally took that, it has a lot more to it. There are any number of more categories, and we decided we overcomplicated it and backed off to just circles, rods, and spirals. So this is starting to try and figure out what am I looking at and how would I visually classify it. But it's a useful data collection mechanism to start to formalize some of your own intuition. And I think one of the biggest messages that we found here, it's useful to work through this process. It's useful to have a tool to help you structure it. And the biggest thing we learned from doing it is your perception of what you think you see changes as you look at more images. What you thought you saw when you held it out at arm's length and looked at the group of images is not the same thing that you find after you have manually classified a couple hundred of them. So this is a useful kind of tool. This is starting to formalize that classification. You can run this through multiple, take the same data set and give it to three or four different people and start to collect some consensus around what is this shape that I'm looking at? Do I understand how to classify this thing? This is a good way to get started. This is how you bootstrap into starting to label your data. Adam,
I
any
think
other key findings here?
Well, yeah, one thing that you mentioned, perhaps you have more than one person kind of working on this sort of thing, this idea of okay, we've taken an image montage, we've used some technology to sort of break those apart and create these individual images and start to label them, and we think we know what we're looking at, right? And we think we know how we should characterize all of these things, but in reality, we probably don't. That probably gets refined a little bit. And individually, we might introduce a bias to that process. And bias is a term that you'll hear a lot as you read, you think through the development of machine learning algorithms and building models, to be aware of is that, in creating this data, we don't accidentally or purposefully manipulate, what we're doing or the labeling uh, in a way that would knowingly or unknowingly give us invalid results. So I think the idea of ensuring very early on like some checks and balances in your processes of how each step of the way, is what I'm doing correct? Does it make sense? Is it still answering the question? In this case, is it one of these three categories? But do I have sufficient information and accurate information about the images that I'm preparing? Uh, to analyze. And is that correct? Because if it's not, downstream, you're going to run into problems with invalid models or incorrect results or anomalous results that you might not be able to explain without some deep investigation. So all things to be thinking of as you're going through this process of labeling and preparing the data.
So I'm trying to structure my data. Here's a first tool to help do it manually. This is how you get off the ground. Those are your take-home points here.
Mhm.
Next slide.
Um, and I think we want to expand on that a little bit of taking this source the source data that you have, any metadata about it, and sort of in this case, we'll talk a little bit more about this later, but we have sort of two types of data here. We've got our original images, and then we also have you're starting to see some tabular data that we've pulled in that has some characteristics that we've derived through those images, and part of this process of labeling of that data prep is also again organizing what you have and what can you tell about the image, or whatever your target data is. um and I think the point that I'm trying to get to is there you may not start with and finish with just the data um, that you think you might. Machine vision algorithms use image data, and manipulate it in certain ways. Um, but that also may or may not be the best way of characterizing images for different techniques. So um, one of the things that we did, and we won't go, super deep into this, but I think it's worth bringing up is as James and I were kind of using this case study and kind of poking at different ways of going about these problems. There are some algorithms that are best suited for certain types of data, and so we were open at this point to saying, okay, let's not just think about the images that we have, but what can we know about them and what tools can we use to derive some more information about them. So we did use a tool like OpenCV, if you're familiar with it. It's an image manipulation library that can be used in Python and C. And we used some algorithmic methods of analyzing those images to come up with other parameters about the images that might be interesting, like the circularity of the images that we see in there as derived by the algorithms in OpenCV. Some information about the intensity of the pixels, the sizes, things of that nature, to give us some additional information, again, associated with the labels that we're creating, to say, well, let's try different approaches. Let's try different machine learning models, all towards, the idea of categorization, but knowing ahead of time that uh, what we might pick off, or think might be the best approach up front, may or may not be the best down the line. So, again, using things like OpenCV, we also use large language models to help us sort of generate some code and think through conceptually how we might do some image manipulation here, to get to our ultimate goal.
And Adam mentioned about three or four different kinds of iterations that we're doing here. The model types, how we're pre-classifying and labeling our images, how much data we're looking at, uh, can we generate more data? These are all forms of iteration on the project. Let's keep going. Next slide. So let's talk about model selection just a little bit. This is a deep area of expertise and difficult to summarize, but we're going to give you sort of just a couple options here. The first one is sort of the regression and classification group of things. Given some set of measurements, what's the probability that this sample belongs to this category or that category? So that's sort of the easiest thing that we could do with the data that we had in front of us. And we want to start looking at, can we get some categorization back out of our machine learning processes that matches the broad categories we put it on in the first place. The previous slide where Adam was talking about OpenCV and starting to extract more data from the image itself, this is more the spatial patterns in the images, right? Using the image tools more in a deeper way. And then there are a number of sort of multimodal options here where we may look at three or four different kinds of classifiers or data extractors, look across them and try and achieve some kind of consensus result among them. So you are not limited to using only one model, particularly if you're not getting the results that you quite want from it.
Indeed, and I think I'd also say, and we're we're not going to go into the depths of necessarily when or why you would pick a particular algorithm over another here, given that's a pretty deep subject. But I think what we want you to take away and understand at this point is there are just a lot of different approaches to working through one of these problems, a lot of different ways to get to that, what question are you trying to answer? Um, and we're working with someone that has sort of the experience and the intuition in the AI and ML space to help understand, okay, based on where you're trying to go, here are the techniques that you're using. That's definitely an area where it makes sense to reach out and talk with an expert, to understand, get some of that experience to help accelerate your journey. Um, it's a fast-paced, quickly changing field with new capabilities, coming online all the time. Obviously there's a lot of hype in the LLM space right now and things you can do there. And there's a lot of different approaches to machine learning algorithms, it being built on data. And so again, this is a great time to say, talk to an expert in the field to help sort of guide, the journey here and help you understand sort of, what you have or maybe what you don't have to help best tune your approach. Um, James, did you want to say anything else about
No, let's
model
go look at some
selection?
data. This is where it gets fun. Uh, just to give you a very quick orientation about what you're looking at. We are trying to do the basic classification that we described earlier. In this case, we're using a CNN with some of our generated image results. So this is using the image more directly as input to the model. If you look at the categorization graph, sort of bottom left corner, we expect things sort of to be on the negative diagonal where you're seeing the darker colors. Those are things where the categorizations are agreeing with what we're predicting back off of the model. Anything off of that diagonal, we're saying, yeah, we might not have got the categorization quite right. We're not expecting perfection here. And in fact, we're going to start to see that show up. You'll notice we have an accuracy column and then a validation accuracy. We've reserved a little bit of the data and we're training on some and then running that validation set back across it. And if those numbers are wildly disparate, what we're telling you is that you have overlearned from the model and your validation set is not as good. You're not getting back quite the level of accuracy that you would hope. So your training is maybe overfitted to your data. And you can also see we've got a training graph, so a number of generations, how many times did we iterate through this, and what sort of convergence did we see? Notice that training graph is very noisy in this model. Just visually, when you see that much noise, we're not converging to something that we like. This probably isn't going to be our best result, but it's an important starting place to sort of learn to read these graphs. And then we're going to give you a couple of different classification methods. So we've got sort of a random forest classifier, which is a way of saying, let's take many different models and vote. What do we think this thing is? We've got a neural network classifier. This is in sort of that regression class of things. How well do we do with just sort of a simple regression? And then the CNNs live more in visual space. They're operating more directly on the image. And so you're starting to see like our first CNN with the 98 accuracy, but this 72 validation accuracy. It's not great. That 98 looks high, and then your validation accuracy looks low. Don't trust that line. It's not telling you what you think it's telling you. Versus if you look at the CNN with the generated data, you're seeing those a little closer. Our accuracy is a little lower, but our validation accuracy started to come up. We're converging towards something. We've maybe got a toehold on the data. So that's sort of how to read one of these plots. Adam, other thoughts here?
Well, yeah, I mean, I'd like to emphasize again sort of the iteration that we're showing here. And so given sort of the details that James has given, just kind of going back and sort of stepping through sort of the rows here, what we're really showing is sort of like this comparison of taking some different techniques. So previously we talked about, different models, different ways of crunching the data to see if we can get to some predictions. And so, like, yeah, with this multi-class regression approach, with 1,400 samples, we had about a 75% accuracy in prediction rate. So, an interesting starting point. And so, then we said, well, can we do better? Can we do better by trying a different approach? So, random forest gets us, a little bit better. I'd note there for those, we're not using the image data itself, right? We're actually using some of the data that we extracted using OpenCV. So they're very different approaches than when we get into the neural network and the convolutional neural network, we're actually feeding it the image data itself, and it's just looking at those images. But we did go through that process of giving it like a very vanilla neural network that was very fast to train, very quick to get results. How well did it do? Yeah, about as well as the regression. The CNN did a little bit better. And then the CNN generated this line is actually where we actually used some techniques to actually generate different data. We'll kind of talk about that a little bit later, but starting to see some of these improvements, and then again weighing sort of like the results that we saw. So as James mentioned, um, we're seeing accuracy in our test data, but when we actually go and validate that against real world images, we see a drop in that. There are reasons that happens that again are probably deeper than we need to go, but obviously the better alignment between those is good. And ultimately, when I think you're going through the process, it's important to know that at some point you're going to have a place where you need to make some value judgments about the techniques that you're using and what is what's acceptable, what works well, and what's the most effective. It may or may not always be the highest accuracy depending on your approach. There may be other considerations, and again, you may need to have multi-step approaches to solving a problem fully. Um, For instance, with the image data, maybe you have some edge cases, right? And so maybe you know that the spirals are really, really tough, or maybe there are some subtypes of that. So you might have a system where, you're doing some coarse grain analysis and classification to say, well, I want things that are either, circular or not circular. And then maybe you're using another model to differentiate between, spirals and rods. It's just an example, but it goes to the point of, well, maybe there's not a one size solution that fits your problem. Maybe breaking a problem down into smaller bite-sized pieces could ultimately lead to a better overall solution. Um, but just just some food for thought there. So.
It looks like we might have a question out in the audience. Adam's going to start here, but I want to make sure that we get questions answered. Please do type them if you got them. Love to hear from you. Adam, keep going.
So with this slide, we just kind of wanted to show a little bit of, it's a difference in, particularly the graph on the lower right, which that's actually showing a model training over time. And as you can see, this is a lot less noisy than the graph before. Again, because of time constraints, we don't want to go into the great depths of what these all mean, but essentially what you're seeing is a graph of the accuracy and the validation accuracy of this model as it trains over time, over iterations, and this is a much cleaner graph, something that you'd prefer to see as opposed to the last one where you saw a lot of noise, a lot of jumping up and down. And when you start seeing things like this, you know that you're getting a much cleaner, probably a more predictable result in a more valid model. This happens to be one that we generated using some synthetic data, which is another thing to talk about here in the class of what happens if you don't have enough data. So for our case, we started out with, roughly 1,400 of those images, which is not really a large sample size. Particularly with image information. What is a large sample size? Well, it depends, but obviously, 1,400 is low. You'd like to see maybe, some orders of magnitude, more information or more data to start off with, and have labeled, in an ideal case, but you may not. That may not be possible for a variety of reasons. And so if you don't have that level of historical data laying around, or you have missing elements or things of that nature, using synthetic data, data that you have created as a representation of the problem might be a way to go. Which is actually one thing that we did here. So we actually used an image model to generate our own set of images that represented sort of the circles, the rods, the spirals. And we did that with about 16,000 images. So quite a few more. And what we found in that case was, still a pretty high accuracy, not our highest accuracy, but a validation accuracy that was also pretty high. So that's data that it hadn't seen before. And some interesting numbers of then, okay, taking this model that we've trained on sort of this set of data that we generated ourselves and reapplying it back to some of our original data was still giving us pretty solid results. And so that showed to us, the capabilities of, using synthetic data to be valuable in approaches like this. And so, all the numbers aside, for the purposes of those watching, the idea that you might be able to bring in data from other sources to help apply to the problem that you have at hand is the salient point, along with the fact that, having much larger sample sizes to build your models on will also help improve your accuracy.
So increase your data size, consider synthesizing data to increase your data size, and hopefully you're getting much, much smoother training. Again, notice we're not saying that the highest overall accuracy is the best model. Higher numbers are not always better in this game. Let's keep going.
Well, I think that, largely wraps up sort of the segment of, the process that we wanted to talk about today. Again, heavily sort of weighted towards the, getting started and sort of like the initial experimentations, the process that one might go through to start uh, wading into the how do I apply, machine learning to a problem. Again, kind of going back to the, that foundational piece of what is the problem you're trying to solve? You're trying to do, some image classification in your lab. Do you need to do predictive modeling of processes, time series predictions, real-time monitoring, um, or just wanting to learn more about the data that you have at your disposal? What is that question, and do you have the data available to start asking those questions? And if you don't, what are the things that you need to do to help prepare that? Is it a matter of connecting systems in your lab to make that data available and combine that with other data to make it effective? Um, is it, technical infrastructure that's needed to make that happen, or is it different approaches to collection or what have you? Uh, it all starts with data. Everything that you want to do is going to need as much as you can gather and as well organized as you can manage. So, um, you know, cross-functionally, organizationally, what are the things you might need to do to prepare to begin testing and validating models themselves? Um, Again, we wanted to keep this, pretty high level survey, so we didn't go into the details of the types of models that you might use, but we hope that through the example and the comments of again asking the type of question that you want to answer, working with an expert in the field to help sort of tune and hone into like, well, what types of models are available, how can those be applied to my data, and what's most appropriate to answer the question at hand. So if it's machine vision, you know CNNs, those types of models are important and effective. If it's simple categorization, random forest algorithms, regression algorithms can be used on that data to come up with predictions. There are a variety. It's a very deep field, and what you find is that sometimes uh, there's never necessarily a cut and dry answer to which path that you choose. So, having someone with the intuition and the experience to help sort of guide that journey, which again will be an iterative one to test and validate the models that you choose, how will they perform, and then to improve those over time. And that sort of takes us to sort of where we ended up of sort of doing this, initial set of experimentation. So at this point in your process, you're probably finding yourself at a point where you validated the fact that an approach will or won't work, that you do or don't have the data that you need, or that you need to modify something in your process. Perhaps you identified, okay, I'm missing a key piece of data that would be helpful, or um, I need more that might inform sort of going back, not necessarily, to the drawing board, but to an earlier phase in the process and saying, well, how can we do a more effective job of collecting and putting data together to drive this forward? On the other hand, you might find yourself in a situation where you found a very effective approach. And then you would be thinking about, okay, well, how do I then take this to like the production phase, right? How do I take this and make this valuable? Because once we've trained a model, obviously we have to sort of take new data and use it again to answer the production type questions that we wanted. If I now have this classification and model in place, how do I plug it into my day-to-day operations to make it work, to gain the efficiencies of developing it? And we purposely leave that part of the discussion to, maybe some of our conversations over the coming months in the Yahara Live series of then, now that you have these models, how do you integrate and make those effective, and how do you scale those within an organization?
And I want to, as we're wrapping up here, I haven't seen any questions come in, but I've definitely seen a raised hand out in the audience. If you've got a question, we'd love to answer it. Please type it in chat. And if not, we'll reach out to you out of band and make sure you get your questions answered. Adam did a great job of sort of summarizing where we got to, but I think I want to add just a little bit about where we're going with this. Um, we are looking at starting to do some little bit deeper dives on this and hoping to offer you a little bit more depth to the content, but we may not do that all live. It doesn't always make the best webinar. So we're going to start maybe publishing some of those out to our YouTube space, inviting maybe some of our expert engineers in to provide a bit of commentary or demonstrate a technique and seeing if we can get some of that information out to you through that channel. Um, if you've got questions, please do ask them. And it looks like we do have one from Roshan. So, apart from modeling, what other services does Yahara provide? Infrastructure, data lakes, Microsoft Fabric, hosting models, orchestration? Yes. We are absolutely available to help with anything in this domain. We've got particular expertise in operationalizing this stuff. So we'll get you set up and we'll get you to a place where you can version and maintain the models so that you've got a clear deployment plan to help with it. We'd love to be that partner helping you with that. But that's sort of why I was mentioning earlier, we need some expertise from your side. You're going to be closer to the data, and your subject matter experts are going to be the ones who provide the foundational questions. What are you trying to get at? And the data preparation. Where is that data? And how would you get access to it? We can't do this without you. We are here to support. We would love to help. We would love to bring that expertise to you, but we need a good collaboration going with your organization for it to be the really successful project. It's part of the other reason that we've mentioned the iterative nature of these. It is easy when you start thinking about an IT project generally to want to assume that you'll put some definitive timeline and budget on it and it will be done on schedule and you will pay X dollars for it. Particularly with iterative projects like machine learning, we want to make sure that everybody is aware that the goal is to get to an early result quite quickly. It's usually wrong, and we're planning to iterate. That shape of partnership, of engagement, takes a little bit of trust up front, and we'd like to find a way to establish some early wins, show that we are in fact getting some results, and that you have a clear path forward to getting something of real value to your organization back out. So that's a slightly strangely shaped IT project. It is not as simple as implement a piece of off-the-shelf software. We are happy to consult about doing this at scale on multiple cloud providers or on-prem. If you've got further questions, please reach out. We'd love to talk. Adam, other concluding thoughts there?
I'd say, great question, Roshan. You're bringing up a lot of technology, a lot of process, a lot of that sort of like thinking of like, yes, how do you kind of take these models and scale them out, build into larger and more operationalized implementations. All really good things to be thinking of, all things that
Let's.
we
I love that we're asking about security on day
yes.
one. Please ask about security.
Yeah. Um, and it's great to call that out that when thinking about these things in the planning phase, even as you're even if as you're considering, well, okay, like here's the problem and here's how we're thinking we want to solve it. Um, that long-term vision of, okay, what will this take? Is this a problem that is very large that needs cloud resources? Can I use structured data lake storage to be able to integrate my data, and how do I fit that into my day-to-day processes? Um, those are all very important things to be thinking about early on and setting the stage for how like one of these projects becomes successful over time. And again, we these are areas where James and I have been talking about, well, like we'd love to expand into this and into the future. So yeah, stay tuned over the coming months, and I think we'll have some more sessions devoted to those types of topics where we kind of dig into the details of how you can take a working model and scale that out.
And I think just for time purposes, we're going to say that that is the question we're taking. But if you've got questions, we are here. Please reach out. And I'm going to turn it back over to Austin. A little bit of an outro. Thank you all for attending today. And we're so glad you were here.